Thank you. Slightly different topic. Within alt VM, specifically blended execution and what we're working on. Okay, so hi, my name is Dino, one of the co-founders of Fluent. And I'll be talk. My talk is going to be called "Your Favorite Apps Are Blended." Actually, before I even go forward, this isn't really going to take kind of drawing from the last talk. That was I liked a lot of that, and I'm missing your name, but I'm gonna instead of talking about the Lego blocks and the way like modularity can help at like the kind of chain architecture layer, or the different layers of chain architectures, I'm actually going to zoom within an execution layer and kind of talk through why modularity can provide extra flexibility and like why using the best kind of tools for each task within one environment can actually help iteration speeds and lead to better apps. So we're going to talk about three things. First one is we're going to learn from how the cloud actually scaled. We're going to assess the state of execution environments, and then we're going to outline a better path forward. So to start, we talk a lot. Everyone sits in Web3 and like screams to the rooftops that we need like a million devs and a billion users. And the reality is like we don't even have like a million of either of those things. So it's like, all right, well, how could we actually get there? What should we be thinking about? And like in my head, I mean, I'm biased. I have like a very much a cloud like dev tooling background, and so I look to where we've actually built apps that do have a billion users and a million devs. And so some of like the social media platforms that we use every day, clearly have like a few billion devs. So what are they doing, and like how what could we actually learn from them? And so one thing that I think a lot of people are probably familiar with at this point is the notion of modularity. And just to kind of like very quickly recap that, it's this notion that you can kind of take what was previously a one monolithic piece of code and break it into loosely coupled services that can talk to each other. And the idea is that you can actually have independent teams more efficiently work on those things, and scale them up, scale them down independently, and you just get like a more efficient system. And so, um, but specifically, we can kind of zoom into one example of let's just Amazon is I think like a typical like website is or a typical like e-commerce app is I think is a decent example. So if you zoom in, there's a very simple example of like a search function, payments function, ratings function. What people have learned over the last 20, 30 years of cloud is to kind of break these things down into loosely coupled services and scale them. And clearly, we're all here at L2con because we've learned from that to some degree, and we've kind of learned to take this blockchain thing and break it into independent components. So everyone's probably familiar with like execution, settlement, consensus, and data availability layers. And what would you say is like the main learning or takeaway, at least for me, as far as the architecture goes? I would say that like using the best kind of tool for each task or each job to be like problem to be solved ends up leading to the best products. But I actually think, what else can we learn from these apps, right? And so let's actually take that a step further. Let's zoom like further into that design, that diagram, specifically the parts, within each individual execution environment. So within each one of these modules, right? So what do you get there? So let's actually take a more probably relatable example. E-commerce apps aren't necessarily super exciting, but let's actually take Figma. Some of you might be familiar with Figma, maybe not, but it's a collaborative web app that was purpose built for the browser. And it like disrupted an entire industry, right? Like it came along and like worked within this very historically very constrained computation environment, enabled functionality that wasn't really possible or easy to do before, and created a $20 billion company that disrupted the space. So now let's zoom in within actually just like the front end of Figma. And so what do you actually see? You actually see it broken down into like two main components. So this is kind of like the middle part of Figma. This is where like the more computationally intensive tasks are being done. And their design, like part of their design goals is to actually have, everything rendered at 60 frames per second. You actually need kind of much more performance than some of the higher level languages like JavaScript is going to give you. And so what they do is they've actually made use of languages like C++ to help meet that design goal. But that really only manifests within like one part of the application. And so you actually look at the other main part of the front end of Figma, and this is the design and layers panel. And this is when people are using this, what's more important when you're developing this part of the application is it's not as performance sensitive. So like they could do it in higher level languages, they could do it in like TypeScript. I'm specifically talking about kind of like the web version of Figma, and it's what's more important there is to have a bunch of tools and software libraries and just like more quickly iterate through that functionality. And so what did they actually learn, right? They oh, and so like what do you do about this, right? So like how do you actually construct that? And so what they did is they decided to use, like I said, two very different languages to solve these two very different problems. And I think we can actually, learn quite a bit from that. And again, kind of principally what they're doing is, using the best tool for the job, and it did, create a better product. Okay, so let's go to another example. Maybe you're familiar with Figma, but it might not like hit home. So let's actually go to Telegram, which all of us probably spend way too much time on. Um, and kind of similar concept, right? I'm gonna zoom into the front end of Telegram, specifically like the web version of Telegram, and for the most part, written in JavaScript. But what they did was actually leverage different libraries to perform different kind of like components within that app. For example, the fast text web for language detection. I'm forgetting like the details of some of these like libraries, but basically they're pulling in like C++ libraries to perform like, for more performant operations. And they obviously don't want to just like rewrite those in Solidity or just avoid them or have those components be off chain. So being able to kind of like take these existing building blocks lets you just more quickly iterate through and deliver better products. And this isn't, these aren't two just like isolated examples. You see this all across the apps that we use every day. Whether they're like apps that are right in front of your face, like Snapchat or Figma or Telegram, like I said, or Netflix, but this is happening in the background too. Like you also have like developer products that are built using these same, using these same programming, like, mental models of like using the best tool for the job. And that's where you get things like Cloudflare, you get, really performant, almost like developer services too. So let's talk about execution environments today. Well, it's a pretty stark contrast. You actually get this world with that, is very isolated and like very constrained. And alt VMs were mentioned before, and that's very true. Like it is very cool that we're like moving beyond just the EVM, and we're seeing a bunch of different alt VMs pop up. WASM-based VMs, move-based VMs, SVM, all this stuff are proliferating, and that's great. But we still think there's kind of a core fundamental problem is that each one of those constrain you to a certain set of tools and functionality. And that's where, in our opinion, this has actually led to more than just the technical constraints, but also kind of like creative constraints. I feel like we've gotten into this like weird cycle over the past like few years where people are just like incentivized to just like copy paste things across different copy paste different like L2s across the space and copy paste different like apps to arbitrage across those R2s and L2s, and just like we've kind of been spinning around a little bit in my opinion for the past couple of years. And that's why we get more ECC side events and other side events. This one happens to be great, but there's a lot of them, and that's why there aren't as many Web3 apps. I'd actually go as far as saying that like we're not going across the chasm into the mass market with this type of technical design strengths and also just like kind of creative design thinking. And we think that there's a better way. And so for Fluent, we're trying to educate on this notion of blended execution. And so we basically have designed this what we call a blended VM that supports apps from EVM, SVM, and WASM ecosystems all within one place. And we've designed the system in a way where like all of these, if you're a developer, if you're deploying an EVM contract, if you're deploying SVM contracts, if you're using kind of like WASM based libraries, all of that works together. It's one state machine, very very nice developer experience, and actually lets you come in with a fresh kind of mental model around how this should work. Come in with the mental model of like, all right, what do I actually need to build? What are the best possible tools and building blocks to accomplish that goal? And just build it. And you're not kind of even thinking like we want to break through this mental model of like, I'm an EVM dev, I'm an SVM dev, and I'm like, we're wedded to certain tooling. And so that's kind of our like opinionated stance on things. And just to make it like, I'll make it a little bit more clear. What you get is this new type of VM that lets you use, ultimately dozens of programming languages, millions of software libraries. There's many, many, many thousands of ready-to-use smart contracts that you could take as building blocks, all within one unified virtual machine. I'll go through a couple examples, assuming there's some time. This is like a very very simple one, just like a demo app, and I don't know how well you can kind of actually read that, but this is an example of like the core kind of logic of a chess puzzle game being in Solidity, but just leveraging some a Rust library to do the actual kind of like gaming engine under the covers. I think the coolest part about this is that like developers get this like extra level of expressivity. Um, when you can actually just build in the language that you're familiar with and like pull in different building blocks from historically different environments, but it doesn't really change anything to the user except like the user just interfaces with a Solidity app in this case, and the Rust stuff is happening on the back end. So all the user actually experiences is either an app that wasn't possible before, now they get to use, like functionality within that app that wasn't possible before, now they get to use, or just a more performant app. So it's just net better. Okay, so just to make it increasingly, but hopefully more concrete, this is actually something that was from over the summer when we just shipped our DevNet. We're by the way implemented as an Ethereum layer two. We had DevNet at this point, and some things were a little bit more theoretical. This is kind of a fun one from somebody in the ecosystem that we work pretty closely with, talking about like building gaming apps across SVM based and EVM based frameworks, which was cool. And a lot of juices are flowing around what could be done in this type of environment. But we actually since then I think have come a decent way, and we haven't actually announced most of the projects that are building on Fluent yet. Stay tuned, like very very soon. But some of the apps that we're working with are like prediction markets that one is built in SVM Rust, but also needs to use ERC20 tokens. We have some kind of DeFi infrastructure products that one in particular managing different like balances across EVM and SVM chains, and it kind of gives them a unified way of doing that. There's some gaming primitives that are built using Solidity, in particular like Mud. And what's cool about this is like not only is that well, even in the examples that are just built in Mud, it actually enables EVM, SVM, and different like WASM languages to compose on top of that primitive. So now you have access to that many more developers for your product. And then another example, there's some like DeFi app frameworks. So like frameworks for building AMMs, things like that, that are just like pulling in Rust agents to help with some of the like the building for users. So we've just started to see like some of this stuff actually materialize, and like the developer experience like actually go beyond like the kind of like theory we had earlier in the summer, which is really exciting. And again, we're going to be announcing like all of these ecosystem partners and applications very soon. So coming full circle, what is the net takeaway? Like we're very strongly opinionated in that the best tool, the best kind of like building block for your app, if you're a developer and you have the freedom to just mix and match these things, you will end up with a better product. And like across the board, we will end up with, as an industry, more creativity and better products. And yeah, it's just a meme. Your favorite apps are blended. Thank you.